The following is from Fall 2011 Math 21 Test 3. In this video, I will do number 7. Tom and Tim work on the problem independently. Now, the probability that Tom solve it is 45%, while probability that Tim solve it is 65%. Now, let's say we use this notation here. Tom is the event. Let the random variable Tom be the event Tom solve the problem, and the random variable Tim be the event for Tim solving the problem. Tim solve the problem. Now, because they are independent, let me use the notation Tom. Then event Tom solve the problem is independent from the event Tim solve the problem. Okay, that's the notation. Okay, now let's see. What is the probability that both solve it? That's the same to say probability that Tom solve the problem and Tim solve the problem. Okay, but because they're independent, then the probability that these two events to happen is probability the product of the probability of those two events. Again, because they're independent. Okay, the fact that Tom can do the problem does not increase or decrease the chance that Tim solve the problem if they work independently. Okay, now then I will plug in numbers. This is a 45% times 65%. In decimal, 0.45 times 0.65. If I multiply that, I get 0.2925, which implies this is 29.25%. Okay, that's the probability that both of them can solve it. Part B, find the probability that Tom cannot but Tim can solve it. Probability that Tom cannot solve it, right? But Tim can solve it. Okay, now again, by independent, because there are two independent events, then the probability of those two events to happen equals to the product of the probability of each event. Okay, now the probability that Tom can solve it is 45%, which means probability that Tom cannot solve it will be 100 minus that, which is 55%, right? And the probability that Tim can solve it is 65%, right? And then every time you compute percentage, especially multiplying to percentage, convert them to decimal first. Okay, never ever compute this directly. 0.65. If I use my calculator, 0.55 times 0.65, there will be 3575 equals to 0.3575, which is 35.75%. Okay. Now part C, given that Tim solved the problem, find the probability that Tom does not solve it. Probability that Tom cannot solve it, given that Tim solve it. Okay. Now this is actually you can do it two ways. But let's use formula method. This is equals to probability that Tom cannot and Tim can over the probability of Tim solving the problem, right? And part B, we get that 0.3575 over probability that team solve it will be 0.65. I changed to decimal right away. And then if you compute this, you will get, I hope you are not surprised, this is 55%. Okay, you can try. Divide that by 0.65. Right? Now, after all, this 0.3575 is coming from the product of 0.55 times 0.65, right? Which if you divide by 0.65, you will get 0.55. Agree? Now, but if you think about that, you can do it actually even in easier sense. Remember that they are independent. Because they're independent, doesn't matter team can solve the problem or not. Okay? It doesn't depend on team. Okay? So this is equals to the probability of Tom cannot solve the problem only, regardless they know team. He knows team can solve it or not. Okay? But this is in itself already known to be 55%. Right? Okay? So you see that part C can be a harder question, but it is actually not that hard. Okay? Just imagine if I twist the problem, if just in case I twist the problem and I say, given that Tom solved the problem, find the probability that Tim does not solve it. If you use the first method, it implies you need to redo part B. Right? You see what I mean? Okay? Because the first method here depends on have you done part B correctly or not. Right? Okay? But if you have some understanding about independency, then you know that the probability of the conditional probability of two independent events is unnecessary. You can take off the given and just work on the first one, as if there is no condition. Okay, so this is what makes this question number 7 is more difficult for some students, because they don't realize the need of or the usefulness of two independent events. Now, independency makes problems supposed to be easier. Okay, that's why we want to be independent, right? Okay, now this is from fall 2011, Math 21, Test 3, number 7.